Today we're going to briefly talk about elasticity. In our case, how sensitive are consumers, or you could say suppliers, to a change in price compared to the change in the quantity supplied or the quantity demanded. So I'm going to be speaking in terms of consumers and quantity demanded. So if you think about how sensitive you are to a price change of, say, Snickers, you're relatively elastic. If the price of Snickers was to go up a little bit, you might substitute away to a Butterfinger or a delicious Milky Way, or maybe 100 Grand or Nut Rage, or one of those other delicious candy bars. But for example, say you really like smoking cigarettes, there aren't a lot of good substitutes for that. So if there's a change in price, you're probably not going to change your consumption of cigarettes all that much. So we have a mathematical formula to do this, which is percent change in quantity divided by percent change in price. So we're looking for how quickly these things change. So if the price goes up a little bit, what happens to your consumption? So if the outcome of this formula is 1 to infinity, the good is defined to be elastic. If the outcome of this formula is 0 to 1, it's deemed to be inelastic. And if it's equal to 1, it's considered to be unit elastic. The original price of Snickers is $1. When the price of Snickers is $1, I purchase 50. If we increase the price of Snickers to $1.25, I might only consume 10. Reason for this is maybe I just want to go out and buy some Milky Ways where the price hasn't changed, or maybe I'll get a delicious Butterfinger instead. We have our formula, percent change in quantity divided by percent change in price. To find percent change in anything, we take new minus old divided by old. So, to find percent change in quantity, we would take the new quantity, which is 10, subtract the old quantity, which is 50, divide by the old quantity, which is 50. Now we need to find percent change in price. The new price, which is $1.25, minus the old price, which was $1, divided by the old price, which was $1. We get 0.25 or 25 cents divided by $1, and that's going to equal 0.25. Percent change in price, 0.25. 0.8 divided by 0.25 should come out to be 3.2. And usually, for simplicity, we just drop the negative. So in this case, 3.2 is in that range of 1 to infinity, so we would define Snickers as being elastic. So now we're going to give an example of cigarettes and what the elasticity of demand for cigarettes might look like. We have P1, the original price of a pack of cigarettes is $5. When the price is $5, the quantity demanded is 10. If we were to, say, tax cigarettes at a tax of $5 per pack and raise the price to $10, I would still purchase 9 packs of cigarettes. So, to figure out the elasticity of cigarettes, what we would do is percent change of quantity, new minus old divided by old. So the new quantity is 9, minus the old quantity, which was 10, divided by the old quantity, which was 10. So we get negative 1, or negative 1 over 10 equals negative 0.1. Now, what we need to do is figure out the percent change in price. So there's a negative 10% difference in the quantity demanded. So now for price, we just go to the new price, which is $10. We look at the old price, which is $5. Divide by the old price, which is $5. So $10 minus $5 is 5. So we end up with $5 divided by $5, which is equal to 1. So then we have 0.1, negative 0.1, divided by 1 equals 0.1 if we take the absolute value of it and just worry about that. So 0.1 falls between 0 and 1. The demand for cigarettes is inelastic.